Alright, so we are on lesson 2.3 rotations. We're only going to get half through today. We're going to do this in 2 days. Exploration today, and then examples tomorrow, which goes a little deeper. So, things that rotate about a center of an object. Example, a wheel. So I have the axis, and I have the wheel, and it spins around it. What's something else that has a center point and it circles around it? I don't need objects that can. Last class was like, a donut. Or your trophy. Well, yes, I can make a center point and spin it. But what's a real life example about that? Ainsley?
Like one of those globe things.
Okay. So globe, we have that axis, and then we can spin the globe on it. Ben? A dreidel. I don't know if I'm spelling that right. Is it just like that?
That one thing.
Okay. Okay.
Or like the sky. Or like, no, like what? Earth.
Okay, so Earth.
Because it spins.
Okay.
That math tool thing that's put out.
Protractor.
Compass. Protractor is that hemisphere. So, protractor.
Because of the word.
No, I'm saying compass.
That word math tool.
No.
Oh, I have a good one.
How about what?
Locker combination thing.
Oh yeah, kind of like your locker thing. Locker.
You know what?
Lock.
It's called a dial.
Ooh, dial would be good. How about something that's not in the center it rotates, such like the windshield wiper?
My
has a
sister and I
flick.
roll around her.
That would have been in the middle.
No.
Anything around.
No. Nobody likes it.
What else would have like maybe a pivot point? But I would say that kind of go, they circle all around it. A clock would have been in the first example, the clock is. Watch could have been the first one.
What about a light bulb?
Yeah, switch.
Troy, are you just naming random things in the room?
Yeah.
Switch has a starting point and it rotates. Okay, I don't know how to spell that, so I'm not going to put it. It's like math. Alright.
An arrow.
So, let's get started with more today. Now that we're thinking about things that are rotating, Parker. Now that we're thinking about things that are rotating, we're going to work on rotating figures in a coordinate plane. Once again, what you're going to do is this example that we did kind of before. And I should have, let me get another example of this. 2.3 exploration. Here's what I want to do. I want you guys, I got to turn for the recording on here. What I'd like for you guys to do is turn your notebooks so we're at I got the wrong one. 2.3 rotation exploration. Alright. There's a couple things I want us to do. And I'm going to kind of model it with the first part. Troy, wait. This is going to be the only time I'm stopping and asking you guys to pay attention. What I want you to do is I want us to draw a triangle. And let's do it in any one of the quadrants. It doesn't matter. If you use your reflection paper from before, so if I get out my reflection paper, so this was mine from before. So I'm going to go ahead and I'm going to make my triangle this time over here. I'm going to label my points.
No.
What I need us to do, Troy, do you not have your stuff ready like you're supposed to?
He's going through my stuff, Mr. Sissel.
Do you have a writing utensil, Troy? So then that means I have to mark you down because you didn't come to class prepared.
I have a writing utensil.
Okay.
You don't got a writing utensil. I got one.
Here's what I want to see from you guys. I used my same transparency paper. I copied my shape, and then it's telling me to rotate it. I'm going to pause my video. I'm going to give you guys about 2 minutes of exploration time. Here's what I want you to do in that time. We know that this is quadrant 1, 2, 3, and quadrant 4. Those are our 4 quadrants. What I want you to do for your experimenting, write down in each one of the quadrants what were your 3 points. So I'm going to do A, B, C. What are the coordinates? Like for this one, A is at 7, 4. B is at 7, 1. And C is at 4, 1. Then I want you to go to the quadrant next to it and do the same thing. A, B, C. Do all 4 quadrants. It won't take you too long. If you don't completely finish, it's not graded, but this really, I promise you, will help you. Okay? Okay, I'm going to pause there. Alright, so I'm going to come back to mine, and Ainsley made a good little comment while she was doing hers, and that's what's going to lead into this beginning discussion. So, Ainsley, will you say it loud so everyone heard what you were kind of asking about?
All I said was, isn't the coordinates going to be like the same?
Alright, so she was saying when she's doing it, she's thinking that they're going to be like the same. When we do a translation, we learned how they're just going to add or subtract and kind of follow on and depend on where we were at. When I translated, I added or I subtracted to my coordinate points. When we did reflections, if it reflected on one of the axes, we said it changed from positive to negative. Oh, please. Change from positive to negative or negative to positive. Now with rotations, we're going to see what the change is. Now, here's my quadrant 1. In quadrant 1, I used my transparency paper to write down my coordinates. A was at 7, 4. When I rotated one turn, which was 90 degrees, and it came down here in my triangle, it put it at negative 7, 4. Oops, that's quadrant 2. I'm looking at the wrong one. Quadrant 4. I got to go to quadrant 4. My A became 4, negative 7. If I look at the two, 7, 4 to 4, negative 7. When I turn one turn, my coordinates are going to switch. Zachary, this is your one warning. Then I mark you, and then I send you out. You should have your notebook open and be following, not just playing around. If we do one turn at 90 degrees, all right, one turn, 90 degrees, you are going to see that our X and our Y coordinates, they end up switching. If we did 3 turns, that's going to be 270 degrees. And they are also going to turn. 3 turns would have been 1, 2, 3. And I would have been in my second quadrant, 7, 4 to negative 4, 7. We also would have flipped my X and Y coordinates. Same numbers, just flip their position. Okay? The reason is, actually, can anyone tell me, think about this real quick. I'm gonna show you my transparency paper. See if you can figure this out. Here's mine. Okay? When I turn this one time, why do you think my X and Y coordinates flipped? Why did my X coordinate become my Y become my X?
Because you flipped over the X-axis.
Yeah, that's exactly it. My X and Y axis switched. Remember, look at this label right here. This says Y axis. It's up and down. But when I do one turn, my y-axis is now acting as my x-axis. So I flip my 2. If I did 2 turns, my y-axis is back to being a y, but it's upside down. So when I look at my quadrant 1 to 3, we see that the x-coordinate, 7, 4, and negative 7, negative 4, they are the same numbers. But we're just going to have to decide where should they be for positive and negative. Okay? This is kind of the biggest thing. What I'm wanting us to make sure we're understanding. This part with the coordinate points is going to be the next day's assignment, where you're going to have to do coordinates. But what I want you to notice is if I do one turn, so from quadrant 1 to 4, if I do one turn, my x and y switch. But they stay the same distance from their x-axis. Notice, right here, it's still the same distance away. It's just, instead of being y, this is an x-axis. It's still the same distance away here. It's just that became the y-axis now. Okay? So, what I'd like us to do is turn back to your foldable, and let's fill in some blanks. Purple sheet says rotation. Rotation is a transformation in which a figure is rotated about a point called the center of rotation. The number of degrees a figure rotates is called the angle of rotation. It is also called a turn. So a lot of times we will call a rotation a turn. Actually, why don't you take notes? Now, why don't you open up and get on your OneNote first? Like not now. Yeah, later on. Alright, so there's a couple things I am going to ask you to probably draw in your notebook real quick. I'm going to make it is also called a turn. Okay, I'm going to draw somewhere on my paper just to make sure we understand for what we will be working with right now. Now, I can turn anything any amount of degrees. I can say turn it 33 degrees, turn it 67 degrees. We will do it a little bit simple. In your homework today, you're also going to be doing it simple. You have to tell me the terms. Here's a couple of terms that you have to know. If I start here, and I go this way, this is called clockwise. Clockwise, always make sure that it's like you put a clock down on it and you look at which way the hands would move. Clockwise is turning to the right. Today, you are going to be using that term on your homework because I'm going to ask you, how did something turn? You're going to say it turned clockwise 90 degrees. That's what we're going to see. We haven't got to that yet. Okay. The second one we're going to look at, what's it mean if it goes the opposite way then?
Counter.
Yeah, counterclockwise. And then there's one more thing I want us to put in there. The last thing I want us to put in is what we are going to be doing. For right now, we're only going to turn in increments of 90 degrees. So we're going to say 1 turn, 2 turns, 3 turns, 4 turns. There's 360 degrees in a circle. Because we have this, it like made our circle. And if you just did right through the middle, and you had two of the diameters, it'd make our little coordinate graph. When we turn 1, we're going to call that 90 degrees. Every section is 90 degrees. So if we get used to that, each one of these is a 90-degree turn. What is important is that even though each one is 90 degrees, and this is why I'm having you put this on here, is because, like our next one, we're going to ask you to go 270 degrees. The 4 that we will use is 90, and then 90 plus 90 is, yeah, so this one is actually from here to here. That's 180 degrees. So if I go from here and I turn 1, 2, 3 times, 3 turns would be 270. Our main terms that we are going to use are 90, 180, 270, 360. Okay? That's what we're going to start off with today. So, let's go to identifying a rotation. You must rotate a puzzle piece 270 degrees clockwise. Now, here's what I have you do. Let's see if you guys can do this together at your table. I would use my transparency paper, tracing paper. Go ahead and put it on there. Make sure you have your X and Y axes and copy that puzzle piece. So everyone do that part first. I'm going to go back to my screen. Real quickly. So I'm going to do it just like this. So I put in my X and Y axis. I copy the puzzle piece. What I want you to do is I want you to turn this 270 degrees and decide what will be your answer. I want to come around, I want to see on your foldable where you have the answer. Show me the transparency paper and what you think it will be. Huh? Ryan, what should this shape be if I turn it 270 degrees?
Oh, I'm so freaking dumb.
I just put the football.
It's not plagiarism.
Wait.
I'm just starting. Third. Here's what I would do. Whoa.
Oh, wow.
1 turn. 2 turns. It's tracing paper. Alright, what did you get? Let's see, who has the answer that they're confident with it? Sabrina, what'd you get?
B.
B is incorrect. Oh, it sounds like a couple people had B. Ryan?
C.
C is correct. Now, let's look up here and I'll show you exactly why if you made a mistake. Okay, I've copied my page, right? 270 degrees is how many turns? 3. So, I'm going to line up my X and Y coordinates. So, I'd go 1 turn. So, after 1 turn, it looked like that. 2 turns would look like this.
But that still doesn't look like C.
3 turns. 3, we'd have it up, left, in the opening. So it should be C. Can anyone real quick tell me what was D? D is one that we should have been able to eliminate. What is D?
D is the 360.
No, if it was 360, we'd be right back. Remember, if it was 360, we'd get right back to the original.
A reflection across the y-axis.
Awesome. Good job, Miles. D is a reflection.
Yeah.
Here it was here. There's the reflection. That's something I'm going to tell you guys right now to help you on a quiz or a test or anything you're doing. If you ever can identify how they got the other answers, if you're not sure how to get the original answer, but you know how they got the answer on other ones, then you can eliminate. Like I know D is a reflection, so that's not the answer. I can see C is a rotation but a wrong way. They turned just the shape. So remember, right now we're spinning around the axis of origin. Let's see if you guys can do this one. Which figure is rotated 180 degrees about the origin? Use your transparency paper. I'm going to pause, talk to your neighbor. I'm going to give a dum-dum to anyone who can get this right. To one person.
Really hope
Okay.
someone slaps you one day.
Let's calm down. What is my correct answer, Sabina?
Yes.
Huh?
No.
No.
A, B, C.
Ainsley.
B.
B
Wrong. I got it.
is correct. So, oh,
D somehow.
focusing, guys. I'm going to show you a couple ways how you can keep reusing your paper. So, but I like that you participate. I don't care if you miss it. Okay,
How did you even get that?
look. If we look at here,
Oh shit.
this is how you should use your transparency paper. I line up. Here, I'll turn it this way so I have more room. I line up my X and Y axis on here, and I'm going to copy the picture over. Okay, now, if we're turning 180 degrees clockwise, how many 90-degree turns is that? 2. So I turn till my axes line up again. There's 90. There is 180. So my picture would look just like this, which matched B. Okay, one of the biggest things I want us to get from today is also noticing this distance right here. Even when I rotate around, since I'm going, you have to think how many times I'm turning. But that distance, which is, here I'll use red, this distance from here to here stayed the same. The only difference is after one turn, it's that distance from the x-axis. On 2 turns, it's still from the y-axis, but it's going to change if the x was positive or negative. It's now positive. When I go 3 turns, it's now from the x-axis. This is going to be a little complicated, but we will work on it tomorrow. If we don't have school tomorrow, which is a good chance of it, we will do this on Thursday. Okay?
Well, y'all
Alright.
will be cheering. You're still here June 6th.
I'm not going.
I can't though, so.
Alright, so I'm going to stop there. You guys, we're at a good place. You will, you're going to see, if you want to kind of get prepared, The next day in class, we're going to start looking at the coordinates. We already did a preview for that. Okay? I'll kind of make a good set of notes where we can have like a cheat sheet to help us. But I want to look at your homework today to make sure everyone does it correct, because there's a couple parts to it. So, homework.
Unless they do like spring break.
All right.
I can't do that.
Now, pay close attention. Shh. Guys, you can talk in about a minute when I'm done with this. You know what time left in class.
Nobody's asking you.
Your assignment is 2.3, day 1. Okay? Now, pay attention to this. On 6, 7, and 8, in the instructions, describe the relationship between the given point and point A, 2, 7, in terms of rotation. So, we're comparing, Troy. We have point A at 2, 7. If point B became 7, negative 2, how did that rotate? There's 2 things I want you to tell me. 1, turn clockwise, or B, turn counterclockwise. And then the second point is, how much do I need to turn? Turn 90 degrees, turn 180 degrees, turn 360 degrees, 270, so 90, 180, 270, 360. Use your transparency paper. You do that on 6, 7, and 8. On 9, 10, 11, and 12, is it a rotation? If the answer is no, you're done with that question. So if it's no, you're done. If it's yes, you must do what you did on the first part. Tell me what the rotation is. Clockwise, 90 degrees. Clockwise, 270 degrees. Could we ever go counterclockwise? Yeah. Clockwise, 90 degrees is going to be the same as counterclockwise, 270 degrees. So we probably use just clockwise most of the time. So, for 6 through 12, when you describe the rotation, you have to say clockwise and how many degrees. 90, 180, 270, or 360. Okay? That's your assignment. To be honest with you,